I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about the routing algorithm. The outcome of the routing algorithm is which is determining the best path from source to destination for data transmission across the network. These routing algorithm which finding the optimal path selection, which ensures optimal path selection. Here, with help of this routing algorithm, from the multiple other path, we can find the best path or optimal path can be found. And resources can be utilized very efficiently by using these are the routing algorithm by finding the shortest path and reducing the any fault or the tolerances can be reduced. Here this is the outcome of the routing algorithm, and the other outcome is which leads the reducing any delays, and it is improve the performance, reliability, communication should be very reliable. So these are all the outcomes of the routing algorithm. So what is a routing algorithm? Routing algorithm means now generally we can use in order to traversing the other packets from source station to the destination station. It will in between the source and destination number of other routers will be arranged. Via these other routers now, thus that packet can be other transferred with help of the routing algorithm. The network layer must be determined the best route through which now the packets can be transmitted. Here is with help of this routing algorithm over this other network finding the best route. Number of routes, number of other paths are available while transmitting the data from source to other destination. Among the number of paths now, best path can be found by using the routing algorithm, that is a routing protocol. So through which now the packets can be delivered from source to effectively, reliably we can deliver the packets from source to destination. Here is for that now we are using routing protocol. So is a routing algorithm now. Routing protocol means this is a routing algorithm. This routing protocol now which is framed with a set of rules and regulations. Based on this, with a set of rules and regulations, finding the best path from the source to destination. Source to destination now, which is find the best path. Here is best path means now it is a least cost path from source to destination. The best algorithm, routing algorithm, traveling salesperson problem. In a traveling salesperson problem, the salesperson he need to visit the all cities from starting source to the ending destination. Starting source, he started from the source station and he need to visit the in between the source and destination. Whatever the other cities is there, he need to visit all the other cities. Here he is visiting the all the cities now by using the optimal, by finding the optimal path now. So by finding the optimal path, easily, effectively, the cost also reduced for the traveling sales other persons. So this is the best the example. It will be applicable. Generally, routing. Generally, it is a process of forwarding the packets. It is the process for forwarding the packets to the destination. That means now forwarding packet. Forwarding packet means now from source to destination. Whatever the packets now we are going to forwarding, in between these the number of routers will be arranged. Whatever the packets now we are going to forwarding, that will be stored in a routing memory. That router's memory storing after some time now that will be forwarded to the another router. Like this now, via this number of other routers now, the data packets can be forwarded to the destination. The required destination for whatever the destination is identified, that particular the identified as the destination, the packets can be forwarded. But here the best route can be found by using the best route. Best route means now shortest distance route, optimum route. That optimum route now, after finding the best route or optimum route now, packets can be delivered. Packets can be delivered from the source to destination. For finding the best route now, we are utilizing the routing algorithm can be utilized. Here is now the classification of the routing algorithm. Classification of the routing algorithm. The routing algorithm can be classified as a adaptive routing algorithm, non-adaptive routing algorithm, hybrid algorithm. Hybrid algorithm now which is combine both adaptive and non-adaptive. Here types of routing algorithms are adaptive routing algorithm, non-adaptive routing algorithm, hybrid routing algorithm. Further, these adaptive routing algorithms are again categorized into isolated, centralized and distributed algorithms. And non-adaptive algorithms are categorized as a flooding and a random walk. Hybrid, which can be again further categorized as a link state and distance other vector. So this is the types of the routing algorithms hierarchy. Adaptive algorithm. Adaptive algorithm means now an adaptive algorithm, also we can call it as a dynamic routing algorithm. By using this algorithm we can find in the shortest path. All algorithms now, whatever the algorithms we have discussed, all the algorithms can be used for finding the shortest path. Here is this dynamic routing algorithm that can be changes their route, that can be changes their the routing of the decision. Depends upon the what type of the network or the topology we are utilizing over the data transmissions, or traffic load of the changes. That means here the network topology, it may be the mesh topology, star topology, ring topology. Depends upon the topology, the routing decisions will be the changed. So this is a dynamic routing algorithm. That is an adaptive routing algorithm. So it should be change the routing based on the topology, network of the topology. That means here in this adaptive algorithm, routing algorithm, generally we are using the parameters are hop count and distance, estimated transit time. These are the parameters that can be mainly used in a adaptive routing algorithms. By using these other parameters, now the decision will be changed. The decision will be changed according to this the decision. The packets can be delivered to the destination. Here, the adaptive routing algorithm. Further, now we are classified as centralized algorithm and isolation algorithm, distributed algorithm. Let us discuss one by one. First, centralized algorithm. What is a centralized algorithm? Here is the centralized algorithm. So it is also known as a global routing algorithm. The centralized algorithm here, which is also known as a global routing algorithm. So it computes the least cost path, which is the computing the least cost path between the source and destination. By using this global routing algorithm, optimum path, minimum cost path can be defined by using the global routing algorithm. That means now source to destination by using complete and global knowledge. Here is how it is finding the minimum cost or optimum the cost means now, which is using the complete knowledge or global knowledge about the network. Now, when it is finding the minimum path means now, whenever now having the entire knowledge about the network, whatever the network now we are utilizing for communication, or global knowledge, then only easily and effectively, reliably we can finding the optimal cost. Here is these are the centralized algorithm generally, which takes the connectivity between the node cost. Generally the connection can be taken node cost and a link cost as a, it will be considered as a input. This algorithm can be considered as input as a node cost and a link cost. These are the combination. Now the algorithm takes the connectivity based on this the cost value, node cost value and a link cost value. So it will be connected the nodes from whatever the nodes now we have arranged between the source and destination. All the nodes should be connected based on the node cost and link cost. Link cost also can call it as a edge cost. So this link state algorithm generally we are referring it as a centralized algorithm. So this is a centralized algorithm here, which is, since now it is aware of the cost of a total nodes or link throughout the network of each link in a network now, which is having the aware of the node cost and aware of the link cost. So these link state algorithm or centralized algorithm. Isolation algorithm. Isolation means now it is an algorithm that obtain the routing information. Here is how to traveling the other packet from which packet to which packet. Now we have to travel now by using the local information, then gathering the information from the other nodes. This is so it is an algorithm now that obtains the routing information by using the local information and gathering the information from other nodes. Here generally in this the isolation now generally we are considering the local information. So local information means now whatever the networks we have considered. Within this other network, whatever the devices now we have other connected, from that other devices the information will be collected from the information from the other nodes now which have connected from the other networks. Here the distributed algorithm now also we can call it as a decentralized algorithm. Generally, these distributed algorithms can be used for distributing the data among the various other devices over the same network or different network. Here, it computes the optimum cost path between the source and destination. By using this distributed algorithm here, minimum cost can be completed. Minimum cost can be found from the source to other destination. For that now, by using the some of the classical other computers now can finding the other path. So in an iterative or distributive manners. Iterative approach or distributive approach. Generally here in the distributed algorithm which is using the distributive approach now, by applying this the distributive approach of finding the minimum cost or optimum other path or optimum cost from the source to other destination. Here in a decentralized algorithm, no node having the knowledge. No node here, whatever the nodes we are using in a distributed algorithm, no node having the knowledge about the network, knowledge about the node cost, or no network having the knowledge about the link cost or network other cost in a decentralized algorithm. Here, that's why the beginning of the node now which is containing the information about its own directions, that is attached link. See, which is this centralized algorithm now, which doesn't have the information, which doesn't have the knowledge about the information and about the network now, whatever the nodes are connected, how to traveling, it doesn't have. So that's why it is the starting node now which is containing the information about one other directly attached links. Whatever the links are attached here based on the attachment link attachment now, so it can find out the best path. Now if you take the one node here, this is a node 1 now which is having the number of links. This link having the cost 12, this link having the cost 10, and this link having the cost 8. Now it is also connected to another node. So it is a source node. It one is a source node. This is connected to the some other node. will be connected to the some other. So this is the destination node. It one is a destination node. This is the destination node. It is a source node. Here is now source to destination. Now if you want to travels now, the cost edge link edges, the cost is assigned to the link. The cost is assigned to the link here. The cost, whatever the cost now which is having the minimum, now it will be traverse through that minimum. It's a cost is 4 and the cost is these 1, 2, 3, 4 node numbers, 5, 6, 7. Here node 3 to node 6 the cost is 4 and node 4 to node 7 the cost is 2. 2 to 5 the cost is 6 and 5 to this 8 node 8 here is the cost is now 5 and here this is 6 to this is the cost is the 6 and cost is 1. Here among the number of other paths, the classical computers now what they are doing now, the classical computers, they are finding the path first now which is searching the in this direction. That means 1 to 2 the path will be the search. If it is a minimum, so it will be considered as a first the traversing. Otherwise checking this one also 1 to 2, 1 to 3 and 1 to 4. All the nodes, neighboring all the nodes now which is the checking whatever the minimum, minimum edge cost now which is traversing the minimum edge cost. From this now connectivities, it can check the all connectivities. Only one connectivity here is now we can take the any number of other connectivities here. From here is the from that now 4 to 7, 4 to the 6. The cost is now it is a 6, it is a 5. From that now among these 2 is a minimum here, 8 is a minimum and traversing from 4 to 7. 4 to 7 which is having the only one edge, that is a minimum 1. So this is the optimal path. That means now if you sum the all the edge costs now, so we'll get the optimum cost, minimum cost. So the persons now, the travelers can be the travels via the minimum cost. Here if you see non-adaptive routing algorithm. Non-adaptive routing algorithm also we can say it as a static routing algorithm. Here is static routing algorithm. So when booting up the network initially, generally now we are storing the information in a router's memory, router which is having the routing table or which is having the memory. So in this the memory which is storing the information about the source information and destination information and source IP address and destination IP address. This routing table, this information stores in a routers which is having the routing table or memory. So based on this the available information now, the data packets can be sent to source to destination. So in a non-adaptive routing algorithm, it is a static routing algorithm. That's why we are calling it as a booting. See here, in non-adaptive routing algorithm which don't take the routing decisions based on the network topology, but but is the adaptive algorithm now which is taking the routing decisions based on the network topology. Depends upon the ring topology or star topology. Based on that network topology now, which is saying the route, the best route can be decided by the based on the topology in a adaptive routing algorithm. But it is not considered the topology is not considered or network the traffic overload is not considered in a non-adaptive routing for finding the best path. Here is the how we are going to finding means based on the information source and destination information availability in a router here. Based on the information availability in a router, based on that now we can finding the path from the destination to source to destination. See, non-adaptive algorithms generally which is categorized into two types. One is a flooding non-adaptive routing algorithm, another is a random walk non-adaptive routing algorithm. Flooding means now every incoming packet, whatever the incoming packets are coming over the other network now is sent to the all outgoing link. Here this is the flooding. incoming packet here, if we take, this is a node 1. Now it is a one packet, it is incoming. That is a incoming of the packet. Now same incoming packet, that is a packet 1, which is sent to the all outgoing links. That means now it is a one outgoing link 1, outgoing link 2, outgoing link 3. That means now the same packet, that is a packet 1. Here also this is the same packet 1, and same other packet can be packet 1 can be sent to the all the whatever the links are connected now, which is sending the all the links. That's why here the redundant, that means several copies of particular packet, several copies are existed here. From now several copies of the node 0 to 1, 2, 3, here same copies, the redundancy is exist. This is a disadvantages of the flooding. Node may contain the several copies of a particular package. This is about the flooding. Random walk. Random walk generally here, in case of random walk, a packet sent by the node to its neighboring node randomly. So here, suppose if it is a one node, whatever the nodes or the neighboring, so which is sending to the it's a neighboring. So here the neighboring nodes are, this is a one neighboring node. Randomly now the packets can be distributed. Here these node which is sending to its neighboring nodes, and this node also now which is sending the packets to its neighboring node. Here also these the packets can be sent to its neighboring node. Like this now, whatever the nodes are the neighboring here, so for that the neighboring node, the packets can be distributed. Randomly walk, whatever the random walk means, randomly walk and randomly distributed to whatever the nodes are neighbor. So for that the neighboring nodes now, the packets can be delivered, the packets can be distributed. So an advantages of the random walk. The random walk, the advantages is the alternative routes are very uses very efficiently. Here is alternative routes will be the very efficiently that can be utilized for data transmission from source to destination. Here is the differences between the adaptive or non-adaptive routing. Adaptive routing, the basic operation means in terms of this the definition. Adaptive routing algorithm is an algorithm that construct the routing tables based on the network condition. Here is in a adaptive, routing tables can be constructed. The routing table here, whatever the routing table now which is constructing, this is a routing table having the source IP address and destination IP address. Based on the source IP address and destination IP address, which is identifying the destination and forwarding the packets to the destination based on the network other conditions. Non-adaptive routing algorithm. Non-adaptive routing algorithm is an algorithm that construct the static table. So it is static table, which is having the static table. So which is this static table now, which is determined which node to sending the packet. Here is this the static node, which is decide number of other nodes in between the source and destination. Number of nodes will be arranged. So we have to send the for which node it will be decided by the static table. Here is in a adaptive routing algorithm in terms of the usage, which is using the dynamic routing algorithms. Dynamic routing can be utilized in non-adaptive routing algorithm now, which is use the static routing. Static routing means now it is a fixed. So fixed path now it will be considered the fixed path. The dynamic routing means now it will be considered the neighboring nodes. But a static is the fixed, only which is going only the single directions. Routing decision are made based on the topologies in a adaptive routing algorithm. So that means now and based on the topologies and network overload. That is overload means network traffic. The topology, if it is a ring topology, the decision will be taken based on the ring topology. Suppose if it is a mesh topology, based on that mesh topology, the decisions will be considered based on this mesh topology, and their decisions, the traveling can be done and finding the optimal path. Here is in a non-adaptive now, routing decisions are a static tables. Based on this, the static tables, routing decisions can be changed. From in a static table means now for which node now we have to send the packets. So it will be decided by the static table. Categorization means now the adaptive routing algorithms are generally which is categorized as a centralized, isolations and distributed algorithm. Three categories now which is divided. One is a centralized, another one is a isolation, another one is a distributed algorithms. Here is the types of non-adaptive algorithms are, which is categorized into the two types, that is a flooding algorithm and a random walk algorithm. In terms of this the complexity, adaptive routing algorithms are very more complex for the designing or implementation. Non-adaptive routing algorithms are very simple for design and implementation. Here, real-time applications. Real-time applications are internet and data communication. Now, routing algorithm generally can be used. Internet and data communication. That is a dynamic data communication means now reliable data packets can be delivered across the network. Now, so the reliable data packets can be delivered. Correct data packets can be delivered to the correct destination across the network. That is a internet and data communication application. And a wireless network. Wireless network means now it is generally in a wireless networks now without the wires the communication can be established. Here is which data optimizes the data transmissions in a dynamic topology. That means now data transmissions can be optimized. Whatever the data wireless network now, how much data want to transfer here, it will be optimize the data transmission. The size of the data can be transmitted in a dynamic topologies like a MONET, mobile ad hoc network, and IoT networks. Based on that now, based on this the topologies networks, it will be optimized. Transport and logistic. Transport and logistic means now navigation apps, fleet systems, finding the optimal delivery and travels the routers. Telecommunication, that is a mobile communication, which is enabling the low latency data transmission. That means a low latency data transmission service means here delay is very less. If you are going to communicating one mobile device to another mobile device with low delay, the data can be traversed, like video calls, any video calls or any 5G networking. Now these are all the telecommunication. Telecommunication always prefers the low latency. Here robotics and autonomous system. So in a robotic and autonomous system also, this routing algorithm can be utilized and finding the best path can be found. Guiding the path planning in a robotics and autonomous here, which is guiding the path or the planning for source station to the destination station for self-driving cars and drones. We take the self-driving cars or drones also now, which is finding the best path and reaching the destination. Best path means optimum path or shortest path. So it can be find this the routing algorithm can be find in a robotics or autonomous systems. Smart grid means now so managing the efficient power flow. Efficient power flow and load balancing can be done in a energy distribution. So this is in this the smart grid. Now this routing algorithm can be utilized. Gaming and virtual reality also. Gaming and virtual reality now. That means now smoothly playing the games and real time this the virtual reality interactions can be. So the feelings now get the players now they will get the real time virtual reality feelings. So with help of this routing algorithm, the driving also, online driving. So So in online driving also, these are the routing algorithm which is showing the route, which is showing the directions. Based on these are the directions, based on this route now. So online gaming can be done, and airlines also. Airlines also, the flights are moving based on the routing algorithm here, which is showing the best path, which is showing the directions, and based on the optimal path now, flights are moving. Here is healthcare. Healthcare also now, which is facilitate the timely medical data transmissions in a telemedicine and IoT devices. Disaster management also. Disaster management means now provide the reliable communications. Providing the reliable the communications and rescue routings in emergencies. If any other emergency, the rescue routings can be provided. The financial system. Financial system now, which is reducing the latency. That is a reducing latency means time delay. Financial systems in a stock marketing, stock trading, stock marketing. So fast the transactions can be executed. Reducing latency can be reduced. Time delay can be reduced for execution of the these are the stock tradings. Here for routing algorithm, the textbook is a Origin Data Communication and Network, and S. Tenenbaum Computer Networking. So this is about the routing algorithm. Finally, with help of this the routing algorithm, now we can find the best path. We can find the optimal path for the any network. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.